So I'm assuming for now we'll have no one on the stream, but you know, it's fine. And so yes, hello, whoever's watching this, hello, welcome back to the stream. So today's stream we're going to attempt to make some kind of spodnet thing, whatever. And hopefully it will be fast. Hopefully. So yeah, we'll attempt at spodnet. I've previously tried to make it, but it was a little bit unstable using spot guns, because spot guns have a tendency to be at different speeds when they come out of the spot gun, which is really unfortunate, because I had everything tick perfect, and so yeah, you can imagine what will happen when you have everything that it works perfectly, but doesn't work. Oh, what did I say? Yeah, but anyway, it wasn't working every time. That's what I'm trying to say. So today's stream, we're gonna try to create a spotnet which will be stable with spot guns, vanilla spot guns. I could use modded ones, but it's a little bit lame. So we're gonna attempt at vanilla, full vanilla, because mods are sinful. So yeah, gonna try to do that. So what do I want to start with? I'm actually not exactly sure. So I definitely need a register to store our data. So I need some XORs. Maybe I already have a register. Oh, register 16. No, yeah, this one. Yeah, I already have this register, so I'm gonna use existing registers rather than creating one. But it's the same register that we have tried to use on the previous stream for interrupts. So yeah, let's try to do that. Wire it, and then let's connect buttons. So this will be the input for our information, and we'll transmit the data. So I'm going to make it transfer 4 bits per like 2 ticks. So 2 ticks per 2 bits per tick, which 2 bits per tick, which should be quite good in theory. But yeah, we're gonna try. We're gonna try it. So what we need to do is we need to make like this kind of ladder pattern, I'm assuming. That will be just prettier and also easier to understand what's going on. It wouldn't slow down, so that's why I'm doing that. But we're going to connect from here to here. Like this. And that way we can transfer the data. Now we'll make an output like this. I'm gonna use that. Whoops. There we go. And so here's our output in theory. Now we need to make the ripple so it would output those sequentially. And so I'm curious, how do I actually do that? Because we need to output it and make sure that the output will be correct. I'm assuming I'm gonna add a small delay between each thing. The problem is, actually, I'm not exactly sure how much delay do I need, because I don't know how much delay the spot guns introduce after distance. So yeah, I'm gonna actually measure that. But first let me remove some of this stuff. that I have on this world. It's a little bit messy. Gonna delete those beautiful creations. So they wouldn't litter the world. Although not that I'm too bothered by it. So yeah, let's now try to measure the stuff. The delay between the spot guns, or I guess the signal. So let's make a measuring stick. So let's go ahead and use 128 blocks. I think we have that much here. So let's try to shoot spot gun from 128 blocks away. And let's see also what spread we have. If the spread will be too much, well, that's unfortunate. But it shouldn't be too bad, right? So 64, 128 actually may be a little bit small, I'm realizing. Yeah, let's try it anyway. So here we have 128 exactly. Let's maybe paint so we could actually measure some stuff more easily. I should have painted it before I spawned them in. Like that. Like that. Okay. There we go. Now I have a small measuring stick, which we could use now. So let's wire it to the ground, and let's place a spot gun, like here, and make it come out exactly like this. So now, what I'm going to do is I'm going to place, probably should shoot it. We're gonna place a small sensor that would receive it. How much high? How high is it? 1, 2, 3, 4, 5. Okay, 5 blocks high. It will definitely change. So let's actually use just sensor. Although sensors don't always pick up the data, I think. Let's try. Let's try it. So 6. Let's upgrade the thing a bit, so it would receive. I don't know. Let's see. Let's use that. Maybe it will somehow do something better. Maybe it will help us to pick up the data. It's off-centered. Shit. Oh, that's not 128 blocks away. Yeah, good enough. And so what we're going to do is we're going to have two things right here. This one is the receiver end, and this is the sender end. Like that. So we connect that. And here we go. Now we can see how much, well, first delay we'll get. Not much. But now what we really should see is, really should check is, by how much do we have offset? Oscilloscope. This captures power. I don't remember how much. I think it captures 60 or 40 ticks, which is nice. It should be plentiful. Okay, so I'm gonna connect that to here, and then gonna connect that to here. So we'll start recording it. Yeah, let's see. Okay, so it was here. Okay, I should have waited a little bit longer till it actually finishes. Okay, 1 tick. Yeah, it shifts by 1 tick. That's not neat. Okay, let's move it even further away. Let's try even longer shtick. So 64 blocks. Let's paint it. What colors do I paint it? I'm gonna paint it black, white, shit, white, black and white. Like that. And I'm gonna save that and gonna lengthen it. Okay, so now we're gonna move the spot even further away. And let's see. How much delay will we pick up right now? So this is 256 blocks away. So we need to make it... Oh, it doesn't even touch the ground, it seems. That's neat. But we need to make it 5 blocks high from the base. As such. Actually, I haven't checked how much spread do we have, but I'm gonna assume that it's fine. Now I just have to connect it. It's so far away that this stuff unloads even, which is pretty cool. That's very far away. I don't know if it will actually hit the... I probably should connect it to logic kit. Shit, it's fine. But let's see how much... Okay, it completely missed it. Son of a bitch. Okay, it's too low. Eek. It's unfortunate that it's so low. Probably should place a logic gate right here, to which I'll connect the button, although it will introduce some tick delay, which is not good. Okay, so 256 is too far away. Obviously. That might be too high now. Yes. So yeah, you shouldn't move the spot gun 256 blocks away. Because it will... Okay. So that's where we're at right now. Gotta mark that right here. Okay, same tick. Okay, 1 tick. It shifted by 1 tick. That's good to know. What in the f... Okay, it's now 1 tick. It's 2 ticks now. Somehow. Oh, what in the world? How's that even possible? So I'm assuming it was so slow that we were able to pick up 2 ticks at the same time. Oh my god, we have to account for that too. Nice. Okay. Okay. It mostly hits the same... kind of 1 tick shift. Okay, here we go. So I'm assuming it was double captured it. So yeah, we have to account for that, but it can plus minus 1 tick. Okay, that's neat. But wait, how actually accurate it is? Hey, it hits pretty well. It always hits the spot. Yeah, hey, it doesn't miss. That's actually very good. So 256 blocks away, and it still hits 6x6 target, which is really good to know. Yeah, we can use that. And by how much? I think we can make it up 1 by 1 block. So how high is it? We can make it 1 block higher, and I think it will be mostly spot on. So it's 4, 8. Okay, it's 9 blocks high. So for 256 blocks away, we need 9 blocks high thing. Transmitter, I guess. I'm gonna write that somewhere. Definitely not in the chat. I mean, the game chat. I misspelled the word high, but doesn't matter. It's for me. Okay, so good to know. I'm gonna just leave that test rig here. Actually, it's more like 10 blocks, but it's fine. So, as we saw, it hits here quite nicely. So yeah. Okay, how do we... So we need to... I think for transmitter part, we can completely ignore this, because it just transmits the data. We can completely ignore it, doesn't matter here. So we can send... Actually, no, we do need to add a delay, because maybe the... So that means delay of 2 ticks. Yeah. For the receiver end, we'll have to... Huh. Interesting. So we could make long... No, definitely not long signals. Okay. We need to make 3... sorry. Yeah, about 3 ticks delay right here. So that means kind of this thing. And here we don't need that. So we will go here, wait. Go here, wait. Go here and wait. Like that. So that will add increased delay. And therefore it should be more stable. At least on paper it should be. Like that. So now when we send it, yeah, it's slower. So that means how much time does it take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About 10 ticks. For 16 bits. That's kind of lame. Or I guess 10 to 9, I'm not sure. And it's kind of slow, if you ask me. I prefer definitely faster speeds for the SquadNet, even though it really doesn't matter that much. Let's make a small tick generator right here. And... Right, okay, so now we can Once again, send the signal. Actually, I could have just done that. Okay. So now, what I want to do is I want, I can't just send this data because, or maybe I can, I'm not sure. But really what I want is I want like first some kind of, first pulse, which will ensure that we're actually, we're supposed to receive the data and it's not some kind of noise. Although, do we need that? Maybe we could actually just send the data and that's it. No, we couldn't, because if we just blindly send the data, then there will be no this tick. And it's useful to have, like, when we can actually synchronize the stuff. Okay. Although, with the synchronization part, there is some issues, because spot guns kind of suck. So we kind of really should use logic instead of this. Instead of spuds, but it's fine. So, what I want to do is I want to send some kind of 3-tick pulse, I'm assuming? So, which will be the beginning of our signal that will ensure that everything is like supposed to be. Yes. And to make 3 ticks long, we can do just that. And bam, it's 3 ticks long. So we send a 3-tick pulse right here. And then after that pulse, we're going to maybe wait another tick. Heck. That's becoming very slow transmission instead of very fast one. Maybe we should just account. I don't like how slow it is. Let's account for just 1 tick instead of 2 ticks of difference, which could happen. Let's just hope that it will be fine. So yeah, this one will send a signal, it will lengthen it, and then we're gonna, after that, when we definitely receive the signal of 3 ticks long. Actually, we don't need 3 ticks long. We can just wait, send, 2 ticks long signal. And then here we can send signal right there. And it should work in theory. So here is a long 2-tick pulse and then the stick transmission. Oscilloscope, let's plop that into here. And let's try that. Just want to make sure it actually works, so I can even connect it like so. So you could even see the data, which should turn out to be pretty cool. And that button will activate the transmission. And yeah, here we go. Oh, that looks pretty cool, not gonna lie. But yeah, you can see that here's our 2 ticks, and then here's the data. Here's the first thing, second, third, fourth, fifth, sixth, seventh, eighth. Right, so how long does that whole thing take? Okay, it takes 10 ticks to transmit 16 bits. Does it transmit the data constantly? So it transmits the data, it does nothing. Transmits the data, does nothing. Transmits the... I should see something like that. No, wait, I do see that. I think I could do that to kind of optimize it. Here we go, now it's 9 ticks. So here is our synchronization signal. Then we have our first tick, that's the data. Then we have zeros, we have our second thing. Then we have zeros, we have our data, zeros, and data. Yeah, that seems to be correct. So, data, 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 and in between there is zeros. That will ensure that our data isn't like scrambled. Although I'm not sure, like when we transmit this, some of the bits here will be smudged. Yeah, well, that's actually quite an easy fix, because we can just OR. Like we can, if we OR this one and this one, and then this one and this one, this one, this one, this one, this one, then it will become fine. Yeah, it should. So let's try to... So what happens when we transmit this? I'm just curious. So on the output we have this picture, right? It's quite nice, it's perfect signal. Then we need an input. Actually, I don't think we need a long signal. We can just not make long signal. We can just make ones and then 0. Because we'll OR them anyway, so it doesn't matter too much. So yeah, so what do we need for the... For now I'll disconnect that. Although it would be... I'm gonna write that signal onto the... So we would know what do we compare to. So I'm gonna write that onto the this glass pane like this, and so that will just make us know how the signal is actually supposed to be looking at. How it's supposed to be looking. So anyway, let's try to now transfer this, and I'm not gonna transfer it that far away. I'm not gonna transfer it 256 blocks away, but 128 instead. Although because we have 4 lanes, we'll have to place 4 of these things. But anyway, 1, 2, 3, 4, 5, 6, 7, 8. So this is our 128th block. And we're gonna make schlop the data transfer right here. And we're gonna try it out. We're gonna try to send the data through this port. And so I'm gonna paint these, so we would know kind of how to connect them. Then I'm gonna spawn this beauty, an incredible work of engineering. Although I did say vanilla. I'm using self-wired XOR gates, so who cares? I'm gonna use these. So these are spuds which can shoot every tick. And this is literally just compressed. This is compressed version of this, and it can send a pulse every tick, so that's why I'm using it. There's 8 spots just in. So yeah, this is quite good for the data transmission. So here I've used 5 blocks up, and it was fine. So I'm gonna continue using just 5 blocks up. because it seems to be fine. I'm not sure how far away am I supposed to place these. I guess I'm gonna place them 5 blocks away. From each other. Like that. There we go, so 5 blocks away, and we're gonna place spots. And I have placed them like that. So I'm gonna do just that here too. And we'll see how actually fast it is at transmitting data. Right now it's rather slow for my taste. I'd love to like have one tick and we'll send the entire data. That would be pretty cool, but we can't do that yet. So I probably will make it proper. Who cares about the proper ticks? This will be actually not cyan, but also blue. Yeah. So let's now connect these spuds like that. And let's try to send the first signal into nowhere. Yeah, they seem to be very, very well... they're stable, that's what I'm trying to say. So that's good. That means we could use sensors. And yeah, that's that. For some reason the image haven't updated here. So I think I could just... Oh shit, I deleted the imported logic gate. Whoops. Like that. I'm gonna remove that here too. I don't know, just like that. So they're 5 blocks away. That means we'll do the same here. Oh no, it will go uphill. Like that. So it should be like that, I think. We're gonna test, maybe I was wrong. Ah, my nose. Okay. Here we go. Here we have those beautiful, beautiful panels. Still seems to be working. And so we're going to have a oscilloscope right here, like this one. And I'm not sure where to connect that. Now let's make it like right here. Okay, yeah, it does seem to hover over ground. Okay. I don't remember in which order I connected the previous one, but let's see. Like that. And then we need to obviously send the signal. And this is NOR gate. Yes, okay, great. So let's try to transfer the data, I guess. Okay, would you look at that? So, yeah, you can already see that the signal is a tad bit messed up by one tick right here. This one is offset. But yeah, now we have smudged signals, but in theory, we should be able to decode them just fine if we'll OR them together. Which we're gonna do right here. We're gonna OR them, and we're gonna see if we'll be able to decode the signal. So 1, 2, 3. So I have this, and this is the input. Yeah, like that. I'm gonna place them like this. So in theory, what we should see is this signal will be completely on because it's the synchronization pulse. Then I have data, 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 data on paper. So how do we OR it? Like that. So that's the bottom signal. Yeah. Like that. And then we have the next pulse. We don't have any data here. Oh, because we're not supposed to, right? Oh wait, those are not organs, whoops. So I have connected that part. Just gonna completely kind of mask out all of the negative signals because I really don't care about those. Okay, I have connected that one. Probably should have made an oscilloscope which doesn't contain these. What? Not sure how those two are on, but whatever. Doesn't matter. Doesn't matter at all. So it seems like the signal was sent correctly. I mean, it was smudged a little bit over a few ticks. I mean, one tick, not a few. But seems like it's the same exact signal. And the last one should be a 9 too. But yeah, here we go. This is our signal. This is how it looks. And that still works, because if we now decode it, what we'll get is, I'm gonna ignore this bit, but first 4 is this. Then we're going to, I need to read like this. So 2 zeros, I'm gonna paint black. 2 zeros, 1 0, but then this one is 0 1 2 zeros, and then at the end we have 1 2 zeros 1. God dang it. But this is our signal. We have successfully decoded it, and it have transmitted correctly. That's perfect. That's absolutely perfect. So now the question is, with an oscilloscope, it's absolutely fine because we're literally capturing the entire signal. But I don't know if it feels okay, man. Clap. Hello, welcome. Oh, Jin. Neat. Think I remember who you are. But yeah, I'm doing scrap mechanic right now, and I'm doing some nice scrap mechanic. I'm trying to make an internet in scrap mechanic currently. So yeah. Where was I? But yeah, I don't think it's quite rational to store the entire input signal, although I'm not quite sure how to make it otherwise. Because in an oscilloscope, I mean, it's quite easy, it's quite trivial. Here we go. This is the entire signal. But I definitely don't want to have 4 registers for each lane. With how many bits it is? With 10 bits. Yeah, 4 10-bit registers doesn't seem like a good idea. So I need to think of how do I do that. No? Yeah, it still gives me the same signal. Okay, let's try. Whatever. So, how do I do that without using much memory? I guess I could have maybe a very fast register, which could store every second tick quite easily. I think I could do that. Then I could, although it wouldn't really help, would it? No, it would, because we could OR the signal. I think. Okay, we have the data here. We can try to make a transmitter here, so it will be fine. I really need to delete this part. Where? Where? Yeah. Just gonna get rid of this garbage, because I really don't need it anymore. Here we go. Now I don't have that. What's going on? Now I can't run. Oh, because it's because of this bazooka. Okay, that's a nice bug. Anyway, now I'm going to attempt at making a receiver for this thing. And it will be definitely harder than a transmitter, because transmitter doesn't really have to do much. So if we'll... Okay, we need to be able to clear the register too. I think. Well, let's attempt at doing that and we'll see how well it will go. So we'll have to clear the register every... I don't think it will... No, it won't clear it immediately. It will take exactly 1 tick, and in that 1 tick we'll skip the data then. Oh, you know what? We can... Why can't I just have XOR gates to which we'll write, and then I could just... What? I think I could just invert. So you can write to these, and then every sometime we're gonna remove the data from that. So it will have to constantly receive data. So we send data right here. Я пойду, удачи тебе. Давай. Спасибо за то, что зашел. So, How do I want to do that? Stupid spot guns. Can't send the data consistently. Hold on, why am I doing all of this? Couldn't I just use a signal lengthener? I mean, I think that would be possible. We can just lengthen the signal by exactly 2 ticks. And then we'll receive... Yeah, let's just try to do that. Let's see how well it will go. If we'll just lengthen the signal. Although I have a small suspicion that... the tick lengthener. So we'll get this. And it will then lengthen this part. And in that portion, it could smudge the bits too. That's interesting. So it will smudge the data. Here it's fine, doesn't matter. But if we have something, let's give it more complex data. Let's give it like a just 10101010. That should be more complex, right? Okay, like that. There we go, just zeros and ones. And in theory, it should become a very, very complicated signal. Yeah, it's a very complicated looking signal. So here it looks absolutely disgusting. Here it looks perfect. Great. So if let's try to smudge it. And let's see what we're gonna output the smudged signal to here, and we'll see how bad it will be. But yeah, it will be awful, because for example, this moment right here. Oh, actually, no. No. It will work. It will work because we have signal lengthener, but we can write only when we actually need to write. We don't have to write constantly. So in theory it should work just fine if we'll do that. Yeah, the signal will be smudged, but I mean, doesn't matter. If at the key points the data will be correct, then, well, it's fine. So here we go, signal lengthener 2.0. Probably should have moved it 1 block so I could kind of have an input. I don't like having everything too close to the edge. It's a little bit not nice, I don't know. Let's try to move it a tad bit. Gun. Yes, hello, medic. I'm currently doing a spotnet thing. Trying to. And currently I'm trying to solve the issue of spot guns doing a bad stuff to the signal. So here's what I received from the spot guns. Located one right there. This is what I received. This is supposed to be this perfect signal. This is the perfect correct signal. But we get this. It's smudged a little bit. So you can see here's the synchronization pulse, And this bit is a little bit off. If I'm gonna send the signal once again... Oh. Here. See, this one moved, this two moved, these two moved. So yeah, I have to fix, have to account for that. And I'm gonna do that using signal lengthener. It's best to have a single spot gun. It's best, but it's the slowest. And work with timing. It's the best, but it's the slowest. That's why I'm doing this. I think Dorf already made something like that. A lot of people have made. Hunter made something like that. Codemaker 4, all of them. A lot of people have tried it. I'm gonna try to. I'm curious what will I be able to achieve. So yeah, I think that's that. Yeah. So now I'm gonna output the signal from here. I'm gonna lengthen the signal, and we'll see what we'll get. I think it will work fine, because if we have the signal correct at the key points, which we will use, then yeah, that works. That should work fine. So let's just disconnect all of those things from the oscilloscope. And let's try that out with the signal smudger 1.0. The sheer reliability of spot guns, hit rate, and accuracy makes it near impossible to transfer any data with this in a relatively short time. I mean, it does transfer the data. I already tested. And apparently the sensors seem to actually capture the data quite accurately, so I don't have the problem with that. It's just, previously, when I've attempted this, I've used like... I had a perfect scenario where the spot guns like were sending with a constant speed. Here, the speed is not constant. As you can see, they sometimes shift by 1 tick. And if I will account for 1 tick, it should be completely fine. So we'll see. We will see what we'll get. So let's try to send it through this. It needs very loose tolerance and a lot of correction and adjusting for it to work, and that slows it down. Yeah, that's the unfortunate part of it. But it still will be much faster than sending 1 bit per like 2 ticks. Okay, so what do we get is... It's shifted by a lot, but it doesn't matter. So let's see. So I'm gonna ignore some of the stuff here, and we're just gonna check the key points. So yes, that's the signal. I'm gonna just ignore the negative part. Okay. So okay, we start, but still, I never did it, so you know more. Yeah. So this is when we start to record the data. That's when we start to actually do something. So this is our starting point. Then we absolutely don't register anything, so we skip this tick, ignore it. We key point, key point, key point, and key point. So, well, the signal is extremely easy. So, let's see. We start register, then at this key point we have that data, this key point we have that data, and this key point we have that, and at this we have that. And that's the correct data. Yeah, this one is messed up, but that's just my test with a perfect... Sorry, when we actually had memory and we could store the entire signal, and that's just inefficient. So, it seems to be correct. It seems to be working. And if we'll try to send it again, you can see it's shifted tiny bit, but the data seems to be correct. So yeah, signal lengthener definitely works. Let's try to have something more interesting for a signal that actually kind of does that, the signal. So what's cool about the signal is that here we send the 9 on this 4 bits, in the first 4 bits. Here we send this bit, here we send this bit, and here we send again 9. So it should be an interesting signal to check. We should get, ideally we should get this signal on the oscilloscope, but we'll never get it with the spot guns. So let's try it, and let's see what do we get. So key point, we have that data. Yes, that's the starting. So here's the 9. Here is this bit activated. Here is this bit activated. And here's the 9 again. And that's correct. So that works. It seems to be reliable. Let's actually now try to make a circuitry for that. So it should be simple. Because what do we need to do is we need to create a XOR gate, and when all of the signal, when all of these things, actually, yeah, never mind, it's fine. So when all of the data is activated, all the data in pins are activated, we're gonna activate this, and of course invert it, and so it wouldn't be able to write to it again. And then we need to make a register to which we could write the data. And I guess I'm gonna make the same ladder as I did at that build. Am I building it in the correct way? This is supposed to be... I think this is white. Or no, wait. No, this is black. Okay, I'll color that. So I wouldn't accidentally mess it up. So we go like that. Oops. Oh no. And that's that. Okay. Now we need to connect these. Just like that. Perfect. Now what I need to do is I need to add things. Okay. Now, onto the signal itself. That's how we do it, I think. So I need to do that. Okay. So that. Here we go. So now we're supposed to send a pulse. Also, I might play with the timing of the when we actually start sending data. Like there is synchronization pulse, and then we need to probably wait one tick. Yeah, we definitely need to wait one tick till the data, because otherwise I feel like it might mess stuff up. Oh, wait. Oh yeah, we're not waiting one tick. So let's wait one tick, and then we will send the data. Oh wait, I didn't register it, did I? I can see that it have done that. So here we have... Oh yeah, the signal is lengthened, so that's why we get this. But yeah, we're just gonna wait one tick till this thing will activate. This does take time. And after that, I think we can input it. And then we can just directly write to the source. Wait. I need to reset them each time we receive the signal. Like that. Okay, so now I need to save them and paste it like that. And then I need to add a gate right here. There we go. That will be the data out. So now I need to connect it. Sorry, to wire it. That looks nice. Feel like I might receive the data a little bit reversed. Not sure, but let's see. So we need to actually reset, and maybe we need to wait one tick. Okay, maybe we need. I'm about to do something stupid. What are you about to do? Or what do you mean by something stupid? Wait, I can't do it. Oh. Well, it's perfect. Okay, well, it didn't work. Oh, because the signal here is activated. Oh, yeah, that. I need to deactivate it. Like that. Shite. Something is messed up. Also, I got font mod running, finally. Oh, that's nice. Okay, something is messed up. I'm guessing the timing. Okay, maybe I'll give it like 2 ticks. So, yeah, I probably should have timed it beforehand. It's fine. So let's just try to send it. Maybe it will work. No, definitely need to time it. I never knew that timers take 1 tick longer than the delay. Yeah. They do be like that. I found out only on your previous stream. Yes. Because it takes time for the signal to actually get to the timer, then the timer activates, that takes 1 tick. Now I understand all the problems with my data transmission thingy. All the suffering. Oh no. Okay, it's consistently bad, right? Am I receiving the data? Okay, here's the pulse. Then we wait 2 ticks. One, 2, 3. Yeah, I think we wait this long. So here we receive the pulse, 1 tick, 2 tick, 2 tick here. Yeah, let's just try to add another delay, I don't know. Maybe it will work. Well. Okay, maybe definitely the timing issues. That's definitely not gonna work. Yeah. I'm not exactly sure where do I when I need to. Okay, I feel like that will be quite a long time. So let's wait 3. I don't know, 4 ticks. Maybe. Let's see how will it go. Okay. Definitely need to actually see the signal. It's a little bit hard to do. I feel like how much? It's kind of pointless at this point. Actually, nah, it's fine. So here's our synchronization pulse. Then we wait some time. So this is wait, we wait 3 ticks? Oh yeah. Wait, what? 3 ticks. Wait, no. Yeah, we wait 4 ticks. Here we go. Yes. This is the 4 ticks. Okay. Bam, bam, bam. So we receive that signal. Here they're all ones at this point. Then we... Oh, it didn't reset. Curious. So we receive, then signal 1 tick. It goes here. It resets this. You know what? Let's do that. So we reset it. So 1 tick, 2 tick, it resetted it. And here it started to... It becomes a 1 tick. 2 tick, 3 tick, 4 tick, maybe like that. Gosh, that's annoying. Oh, what? It's reliably breaking, yes. Something, at least. Okay, that's definitely incorrect tick. Either too late or too... or too slow, I'm not quite sure. Counting ticks is hard. Okay, that's definitely incorrect. So, at the oscilloscope, it's very easy to see that the signal is correct. At here, I'm not sure what is happening. Outputting the signal, it should be correct, right? Okay, what we could do is we could check what data we have Simplifying it could help. I'm not sure what there is to simplify. It's pretty simple, right? But I think I could do this thing. I could check what we get here. What signal do we get here? Because this is AND gates, so... maybe it will do something. Okay. That I might have inverted, may or may not have inverted the signal, but it doesn't matter. It's just I want to see what am I getting on this point. Huh. Okay, that's a definitely very clean signal. Also, I need to really remake this oscilloscope because this part is really annoying. Oh, nice. Okay, that's definitely incorrect. Let's try to offset it by 1 tick. And let's see what we'll get. 9, 10, 10. Okay, so it have missed the first 4. Okay, it really seems like hold on, maybe have I connected these correctly? Maybe let's try to reconnect them. Although wait, no. Maybe I have that. I haven't actually checked in which order these go, although it doesn't matter. Let's just try flipping it, maybe it will help. Because it seems like I've messed up there. No, it was correct. Whatever, let's try it. Wouldn't hurt too much. Though I think I have connected it correctly the first time. But let's see. So try to send signal and we get... Okay, that's certainly more interesting. Still kind of missing this part. Maybe I'm having too much time? What if I'll shift it by that much? Will it fix the problem? So we wait 2 ticks before we actually send the data. Now hey! It have worked. Perfect! Hey! I think it works. Okay, so the problem was I messed up with the how I connected those. Because this is supposed to be black. So yeah, the order here matters. And also I've messed up the timing a little bit. I think... Could I make it a tick faster? I would love to make it a tick faster, but you can see, here's the perfect signal. It's inversed, like it's flipped, but it's still a perfect signal nevertheless. Which is nice. So I'm gonna try to make it a tad bit faster. I have 1 tick faster. And we'll see if we'll be able to do that. Because in theory, so we receive the signal, this activates. That's 1 tick passes. Second tick, this resets. Sorry, this thing activate. And third tick, the signal goes to here. And in theory, if on this same third tick, the data starts to come in, it should be fine. Because in the places where there is one, because it's XOR gate, I think it will just cancel out and won't disable the cell. And so in theory that should be correct, if we'll make it one tick faster. But we'll see, there is only one way to find out, it's just doing that. And making the timer, deleting the timer pretty much. And doing the same thing that I did previously. So let's try this. Okay, that definitely didn't work. Well, that doesn't make much sense to do that. But yeah, I guess I can't speed it up by whole one tick. Which is a bummer. Oh. But it's fast enough, I guess. Because it does receive the data. Here we go. And that it does receive the data reliably. Which is very nice. Unfortunately, I think the distance, the minimal distance that we can get is 128 blocks. Or maybe more. Because at 256 blocks, the bits start to... the offset becomes 2 ticks. And sometimes, so when there is 256 blocks away, like when those things are 256 blocks away, the signal can become 2 ticks long. So I have to make sure that it's 1 tick. So I need to use tick generators and all that mess for even further. But I think we could just use repeaters, although I'm not sure. Maybe we should make it. So it works reliably on... it seems to work at least reliably on 128 blocks away. It probably could work like a bit further away. But again, at this point it starts to have weird stuff. Could add error correction, but no. It's a little bit too much for 16 bits to have a flippin' error correction. Because good error correction will take we'll add like a few bits, and I don't want that. But I think that's fine, that's good enough. It does receive the data. Oh, never mind. You could add a buffer, I think. Okay, mostly reliable. You could add a buffer, I think. Really, I could use this. Okay, so it's mostly works reliably. Like this one. How did that happen? Interesting. Right? I guess it is very hard to have reliable data being sent. Even for 128 blocks, wow. Spot guns suck for data transmission. Which is sad. Guess we could make... I'm not even exactly sure what's happening at like this spot, because it does seem to... Like, what happened here? It was supposed to be activated and like it shifted by 1 tick. What if I wait a bit longer? Yeah, the signal gets messed up, but I'll also add the tick right here, although I'm not sure if that will work like that. Okay, it doesn't work quite like that. Oh, hey, it received the data correctly. Oh god, what? That sucks. Spot guns suck. A lot. Unreliable stuff. And that's unfortunate. So what do I get for the signal then? A. What? Buffer for what? If you're about that. Caveat, because I can't find one. I think I have sent it at some point. But those are squares. Do you want squares for dots? Because I don't have a circle one. I'm gonna try to switch. Okay, it's in show us your projects. I have that. I think I can send you a message. You're Devil, right? Well, anyway, I've already picked you in Discord. Yes. Well, yeah, I have sent you the link to the message with the dot. I have no idea if it's actually... It should be smaller. And also there is an old texture for the logic gate, which I'm using right now. Or not exact the same, I'm not sure if I'm using the exact same as I sent previously. Thanks, yes. Oh wait, yeah. Just doing some unrelated stuff. Okay, well, reliable-ish data in thing. Perfect. Okay, scrap mechanic internet is a bad idea. I've discovered that. At least full vanilla. But I mean, if you're gonna use not full vanilla, that's kind of a bad idea. I'm gonna remake an oscilloscope because these thingies are annoying. So I'm gonna remake the oscilloscope. So it was called Simple Oscilloscope. I'm gonna just copy the name. And I'm gonna make an oscilloscope. Because this one is a little bit annoying. So for the oscilloscope I need the... internet response is a bad idea. Yeah. It's very... idea, yeah. Yes and no. And just realized I can use the... Wait, I already have a register, why am I doing this? I can just reuse the... I can just really reuse this register. Because it's quite fast. And it doesn't matter which bit is the first. Because I'm making an oscilloscope. I can't rotate this. Shoot. Okay, I guess I have to remake the register. Because I want to make this the output. Sometimes they bug, sometimes they don't. Like that. Here we go. So now, I'm gonna make this a register. Okay. Yeah. Well, where am I? Where's the chat? Here we go. So now I'm gonna make a oscilloscope real quick. Well, maybe not very quick, but... There we go. Then I need a pulse which would write the data. Which will be this one. Actually. Yes. Would it be faster if I would reset it and then write the signal? I'm not sure, does it matter? Yeah, let's make it reset first. So I'll just reset it and then Sunday small... Oh, actually, either way we're gonna need a signal that will just go forward, like this. So yeah, what I'm gonna do is I'm gonna make this signal that just goes through each memory bit, and it writes the information to the memory. Okay, let's make it a reset then. Because we're gonna write directly into the memory. And it's just kind of easy, I think. I'm not sure what I've used previously. I think I used this design. Oh, different design, sorry. So that goes into here, and that's our data. That's for data. And I'm gonna make it 40 ticks, sorry, 40 blocks long. So it would be equivalent to storing 1 second of 1 game second. So 40 ticks. So 16, oh sorry, 32. And 48. So I think I need to do like that. And that will be equal to 40 ticks. Let's actually count that. So now 16, 32, 33, 34, 35, 36, 37, 38, 39, 40. Yes. There we go. That's done. Now I'm gonna make place a few blocks. This one will erase everything that is on our in our oscilloscope. Actually, I could have used this connection tool to count how many blocks there is, but never mind. Doesn't matter. But then here we just need to... Oh, yeah, here we also need to connect all of them. Like that. Put the motor point thing in the folder, and it don't work. You need to clear your cache before you actually, before it starts to work. You need to delete the cache for motor point. So you go into the cache folder in Scrap Mechanic, and you delete the cache that is with the name, which contains the motor point. So you can just search for a motor point and it will probably find it. Yes. Actually, maybe I should have... I'll delete the whole cache. Well, that's also a way. It just will take much longer to load the game. Because I also installed the old logic gate thing. Well, you could have searched for the logic gate too, but okay, fine. You do you. Okay, fuck it. I'm gonna do that first. So that's our pulse, that's our reset, that's our thing. So it doesn't matter. Yes. It will make a new one, so it doesn't matter. Yes. Okay, I guess how I can have more than 4 lanes. That I could store, I think. It's more compact. More nice, more yes. I actually haven't tested if it works. But I'm gonna assume that it does. And just gonna roll with it. So how much blocks does it take? It takes actually 800 blocks. Why did this oscilloscope take so much blocks? It took one in a... Okay then. Oh, wait. Oh, because I had an output. Oh, because I'm smartened, and I haven't used the actual output as the screen, but I'm doing that right now. So, sorry, the memory as an output, and I haven't done that in the previous. So I'm doing a not very smart thing by just ignoring the fact that I haven't tested it. So I'm hoping that it just works the first time I enable it. So anyway, I'm gonna paint it and gonna add eight inputs. So that's our data inputs. I am not sure if I do need to synchronize them though. So I need an oscilloscope to make an oscilloscope. I think that makes sense. Not really. I can synchronize it afterwards. It definitely will be out of sync because I first need to reset and then I need to write the data, and reset takes like 2 ticks, I think. So I'll definitely have to account for that. So yes, I guess I could make an activate signal, which would activate each lane if we really need to. Because maybe we don't want to erase the whole thing, I don't know. So by default they will be on. Yes. Not sure if I'm over-engineering it or not, because I don't know if it's really does make sense to do so. But I don't know. They'll be activated from the beginning, so I don't think it matters. I should have... wait, no. I should have placed it a little bit in a different place, because it probably will be harder to connect to. So where do I place it? Right here? Yeah, I'm gonna place it right here. This scrap mechanic feature of doing that, I have no idea if I'm placing, like... I can't tell which way I'm placing the gate, it's a little bit hard. Okay, that doesn't work. Ah, shit. Okay, I'm gonna move stuff a little bit. Actually, I just can do that. So what I need to do is I need to have the activate signal, which will be in this color. And then I'll have some activation things, which will activate each lane if you want to do it. And by default, they will be enabled. All of them will be enabled. So you will erase all of them and write to all of them. I think that's a reasonable thing to do. And then I will have an input for each lane. Just like that. And input will be white. This will be, I guess, green. Painted black. Okay, so now I'm going to connect. So that's our thing, which would send the pulse. Actually, we need to wait one tick. So we will erase first. We'll do an erase. And then we start send the pulse to write data. And of course we need to make sure that we're actually like that. There we go. So then we need to connect. Well, we'll probably... Yeah, we'll sort it out with using logic. I'm gonna test 2 lanes first. So what I'm gonna do is I'm gonna make just a XOR gate and then a button. Or no, not a button. Got all the connect dot and texture gates working. Nice. And I'm almost done with my oscilloscope. Now I just have to synchronize it. Yeah, no problem. Okay, that's a big lesson for me to not trust myself. Yeah, I know what I forgot. I forgot to yes, I forgot to activate when it's actually needed to. It should be an easy fix because we can just paint all of that, some color, and then, or no. I'm gonna fix it quite easily in Advanced Blueprint tool. Shouldn't be that much of a problem. So yeah, I just wrote to the... But why does it blink though? What if I'll just write it? Will it also blink? What the hell? Hand gate. What? This is deactivated, this is deactivated. So what's the problem? I will... Ah? Oh, because this one is activated. Oh, right. Because this is an OR gate. Yeah, it must be an AND gate instead of OR gate. That's my problem. My bad. Here we go, now it doesn't blink, right? Yeah. Okay, a little bit of an oops right there. Now, I'm gonna do some advanced blueprint tool. Some advanced stuff. Kind of. And I'm just gonna fix some of the things that I've messed up. So... Here we go. Now the Y coordinate. Then 11. I really can't see where is my... There we go. Okay, I can paint this, for example, color, just white, I don't know. Just paint that white, and then paint that grayish color. And then from grayish color, I need to connect to white. Y coordinates. Yes. Right, am I connecting to the correct things? Yes. Where is the connection tool? Okay. Successfully made 0 connections. That's incredible. Oh, because it haven't painted the actual blocks. Or wait, it should have. Paint them. Here we go, now it painted it. Successfully made 320 connections. Is that the right number? Yes, it is. Oh wait, I guess I'm gonna recolor it. Well, I'll recolor it after I... There we go. So in theory now it shouldn't do that. And it just doesn't right now. I'm not sure if it does it send the signal. Sorry, the stream have just completely died for a second. Apologies. What is this? Hello Ethan. I'm doing an oscilloscope, trying to. It worked. Yeah, I noticed. Yeah, me too. So I'm trying to understand why does this gate not work. And by not work, I mean it just doesn't activate. So does this have anything? Yes, it sure does. This is supposed to blink once when we just send the data to it, but it doesn't. What have happened to it? This is all on, this is... Now it's on. Ah! I haven't connected these two. That's... yeah, that's problematic. What is going on? I have not scrapmechanic.exe. Yes. I've just remembered one thing. I haven't actually connecting them. Haven't actually connected them. Troubleshoot simulator. Yes. It's awful. Okay, I forgot to actually wire these things. I think that's the only thing is I forgot to wire. Otherwise it should work just fine. It's not only, Scrap Mechanic is not only connection simulator, it's also troubleshooting simulator. That's very nice. Okay, but here we go. Now it should in theory work. Okay, nice. Although this signal doesn't really tell me anything, because I have no idea how much delay do we have. For the actual signal, I'm not sure what I have picked. I know what I can do. I can place another XOR gate. Wait till it stops doing that stuff. And so now it kind of blinks. Not constantly. Which is good. Okay, great. Now I want to have the signal right here. Though I'm not sure. Yeah, it won't capture it. Because the signal is also being sent to here. So yeah, I definitely need to like send the signal here first and then start sending data into here. Or I could just, I don't know, what can I do to actually synchronize it? Because maybe it's already synchronized, although it probably not. Hell, I'm so confused. How do I test this? Okay, so this will register the delay, and in theory, when I do this, I should have a signal on the screen, but I don't. Yeah, that's a good test. So yeah, I do need to add a small delay here. Let's try this. Here we go. Now I have a signal. So yeah, it starts exactly at the same time when this thing starts, which is perfect. That's exactly what I need. And the oscilloscope is done, in theory. Not sure if it's actually better than my previous one, but I hope it will be. Devs should add a way to trigger sensors without moving or shooting crap, or light sensors. Trigger sensors. Yeah. Laser some kind. It would be cool if the Scrap Mechanic had a laser, vanilla razor transmission. I know there is mods that adds lasers. I mean, mods are sinful, come on, everyone knows that. The people that don't know are... Yes, that would create a lot of possibilities. Yes, light sensors would be pretty nice. But Scrap Mechanic is quite bad at lighting, so yeah. Also, I've just noticed a small issue. I have disabled shadows, right? Because I think, why is everything so bad looking? Let's just enable shadows for a bit. I just forgot to add them when I was testing something. So yeah, let's bring them back. More modular creations without wiring. Yeah. Although that would be kind of... Yes. So pretty much add ports. Which would... Yeah, that would be nice. Because Scrap Mechanic bad at physics, or they could just fix the physics, maybe that would also help. But yeah, anyway. Here is my mighty oscilloscope done. I can disable lanes, and let's actually... I have a counter. Where? Yes, this one. Much more perfect counter. So I'm gonna add this much more perfect counter. It's much more perfect because it is. Because it can actually count each tick without skipping some stuff. And so let's just see how will it look like. Should look pretty, yes. Am I connecting the right bits? I think I do. Okay, there we go. And beautiful. Look at that. Looks very yes. Almost. There's a small problem right here. A tiny one. How did that happen? What? Oh, god damn it. Why can't everything be just perfect? Why does this happen? What? I don't... Maybe it's my counter that does that? Is it? It is perfect. That's not how counting works. It's perfectly wrong. Yes. God damn it. Let's count every other tick. It skipped one tick, but it's flipping impossible. Scrapping physics sucks, by the way. Let's count every other tick. Maybe that will help. So that worked. Maybe it was a one-time problem. If it's unreliable, I'm gonna remake it. Like, that's not a good way to do stuff. If it's unreliable and it's like one time, like, it might appear at some point. That's not how I do things. Don't like that approach. So it can count every other tick just fine. It's just that it can't count. Maybe that's the counter then? Let's try with my previous oscilloscope. Because that thing definitely worked. Yes. I have a feeling that this thing is bigger than this thing. High-speed logic tend to break in weird ways. Well, it's not supposed to skip one tick when it's like, that's not... No. Okay, we can't register the entire thing. That's fine. So let's try to do that once again. But with this thing. Maybe it's the counter problem. Maybe it's counter being wrong and stuff. So we're gonna count just constantly. I'm gonna wire that. Gonna reset it and let's try it. Oh god, it's hard to understand what's happening here. That's why I'm remaking it actually. But if I'm gonna just cut that part out. Just gonna delete that and let's see. Okay, I assume that's the counter doing something weird. Maybe actually I don't remember even synchronizing this one. Okay, I'm gonna check this counter after the stream. I'm gonna check it frame by frame. Maybe the counter is outputting something weird. But I'm gonna say that the oscilloscope works just fine. Could try my counter. I mean, can it count every tick? Give me a link and somewhere. You could give me it in Discord or whatever. You could throw it in chat. One minute. It's quite a while. Next stream, we're gonna make ray tracing and scrap mechanic. That's a joke. Although I could try. You could try to render something like a cube of you if you give it a display. You could try. We have rendered a cube with Vilgat before, because we do have a line renderer. Or are you talking about this thing? Display. I mean, we have rendered a cube before. Computer. Yeah. MQ8B can probably do that. Although I don't think I have enough memory for it. I can emulate the computer though. I do have an emulator, so I could add a display for the emulator. And I could try to make that there. Although I'm still not sure if the emulator even works correctly. Like, does it? It should work. Okay, I guess not sure what am I do. So what do I want to continue working with the awful spot guns? You know what? Spot guns is too hard. So I'm just gonna make connections using. Hey, what if I will try to make two MQ8Bs communicate between each other? That should be possible, right? Yeah, I'm gonna try to make two MQ8Bs communicate with each other. It should be very much possible. Before that, I'm gonna store that. Go. I think there is two L's. If you want something hard, you could transfer an image. It's not... I don't want to have... I don't know. I don't want to use spot guns. I'm just gonna use logic transfers, because I do have a... Yeah, it runs. I have this thing, and it works reliable because, of course, it does. With logic. I mean... So... Don't think it should be... Don't think it will be too hard to do. Yeah, let's try to transfer an image. Using logic, because spot guns are too bad for data transfer in big amounts. Yes. So we're gonna make 16 transfers. Yeah, let's try to do that. So I'm not gonna... Here's, we're using 4 of these to transfer the data to here. And so we're gonna attempt to transfer the image. First I probably need some kind of obviously image. Discord, okay. I see. Light cyan for tick speeds. 12-bit binary counter. Yes. Okay, you can't see that on the stream. That's good to know. And if you do, it doesn't matter. First we need the display. I do... Yeah. Yeah, I do see that. Yeah, nice. Okay, well, let's try to log that then. Let's see. Don't you dare laugh at me not seeing where the other side. So, okay. I'm gonna connect... no, not that. And now. That's for the spot, and that's for the spot. Well, I'm gonna assume that it has a tiny stroke right here. Although that's both of my... That shouldn't be even possible. That's both of my oscilloscopes doing this thing. What if I add another tick delay right here? Because that's rather interesting. Hold on, what? I have copy-pasted all of them. And yet only the bottom tick does that? Okay, no. This doesn't make much sense. Let's ignore the first tick of this thing. What? No, that doesn't make any sense. Why does that happen? I shifted it by 1 tick and now it works. Even though those are all equal. So, try a tick going through a line of logic. A line of logic? I mean, this is the... what? Okay, I have a question. What if I'll do that? Fair enough. Fair enough. Okay. I'm gonna pretend that that doesn't happen. And I'm gonna try to offset to shift it by 1 tick. And I'm gonna... I mean like 1 tick on each channel. Well, I mean, if it... I'm gonna log first for... And just in a row, yes. Let's disconnect these. You mean that? Or... I mean, like, take on the channel. Or do you mean... Whatever. I'm gonna try that and... No? 1 sec. Yeah, that doesn't make any sense if I do that. Do you mean send the pulse here, each tick? Or what? Yeah, I'm confused. Are you gonna send me something on Discord? Tick going through a line of logic. Because, in theory, it will work just fine if I will... So the thing is, I think it worked just fine when I have the counter work every other tick. Not every tick, but every other tick. It seems to work just fine. And I'm not sure why. Okay, never mind, it doesn't work fine. But why? Is the... Okay, haven't I... Stop. I'm gonna quickly do... record. Oh, goddammit. And I'm gonna open some programs to check it frame by frame. That's a little bit more reliable. Because then I can actually figure out what's the problem. Okay. I saw someone send me a message in Discord, but I'm gonna check this frame by frame just to really see what's going on. Zoom. Can I? Huh? I think it's supposed to be that. Wait, where is everything? Oh my god. Okay, so what I saw was what did I see? Disactivate, disactivate. That's so weird. Okay, so I think it's actually, this thing actually logs it correctly, I think. Because, I mean, the logic is so simple. It can't, like... So the thing is, let's make something like... Let's make this... I think it actually... The oscilloscope is fine. It does what it's supposed to. Because the logic is really, really simple. I don't think it's the oscilloscope doing it wrong. I think it's might be how counter works. Yeah. Oh my god, they're all in different orientations. That's horrible. But anyway. What I'm gonna do is I'm gonna do that, and I'm gonna log that. Hope the music isn't too loud, but it's probably not. So let's try that. Okay, so... What? Oh, we probably are supposed to disable the output. Ah, no, actually everything is correct. So... The fuck? Maybe I'm wrong and the oscilloscope doesn't work right. Because this is a little bit like impossible to happen. Like if this is off, this can't be on. I have a feeling the link I sent is different test. Yes. Okay, I think it might be my oscilloscope doing something very weird. Hell, okay, I'm gonna load the test and see what's up. That's a great name. This. I'm done loading this. Can have viruses from this. Okay, perfect. Okay, oh, I see what you want to do. That's... Yeah, that's what you meant. Yeah, we'll see how it works. So, okay. That's an clever test. I'm gonna die if it will log this incorrectly. It should be fine, right? Yeah, this is a tick generator. NAND? And it logged it correctly. So pure is proper thing. Seems to be working fine. So okay, I guess that's the counters just do that. They do be like that. I'm already busy trying to make 8x8 display thingy. Okay, that's nice. Yeah, that's how counters work then. Very strangely. That's the answer. Okay, so... Now I have a lot of oscilloscopes. And this one kind of sucks. By sucks I mean it doesn't really work. Not sure why I'm still... Do I still have it on my... Oh wait, wrong thing, hold on. Whatever. So now, what I wanted to do is I wanted to transfer the data using simple logic. Well, simple, yes. So first thing that I need is I need the screen. And I might have just the right screen. That's XYZ screen. That's also DDD. I hate my acronyms because I have no idea what DDD means. Okay, here we go. That's the screen that I like. Wait, do I have... Okay. Maybe not that much now. Because it won't be able to reset 1 pixel right here. Because scrap mechanic has a fucking limit. Look at that. Max connections reached. Oh, it did connect it though. I doubt that it will work though. But let's try. Let's try to... Yeah, see? It doesn't work. This is an AND gate. Scrap mechanic. Axolot games have added a limit for the logic gates. Isn't that smart? Oh, and it have connected from here to here. Wow, that's smart of you, Axolot Games. I'm absolutely not hating it for them for that. Oh, and I can't even connect it now. I gotta love Axolot Games for doing that. That's just so nice of them to do that. Okay, I'm gonna remake the screen a tiny bit. By that I mean I'm gonna have different way of removing the stuff. I'm gonna remove them like this. That's much better way of doing it. And it doesn't hit the stupid flipping limit of scrap mechanic. Like, why did Axolot Games... Why did they do that? That's such a smartened idea. And really it doesn't hurt that many people except people that actually want to make some, I don't know, big logic. Like if they want to make a memory, for example, they can't because there is a limit now. Awful. What a shame. Anyway, gonna connect from the orange, which is a little bit different color. It's orange, I think. And I'm gonna connect it to... I think it should work. 256 connections made. Okay. It should have worked. Yeah, it sure did. Okay, nice. I'm gonna repaint it to black because that doesn't really matter. And I'm gonna paint this dark red with an OR gate. And I'm gonna save it. Okay, so I'm gonna use this as a screen. It's a kind of like a cool screen too, because it has the output from each cell, which makes it actually thicker, but it doesn't matter. So, the screen is done. I'm gonna... What's happening? Okay, nothing's happening. Oh wait, I didn't... Oh god. Don't tell me that I... Oh no, I have saved it like this. Doesn't matter. Okay, then what I need to do is I need to make a... So this is the receiving end. That means I need a receiver. I should have painted these. I'm gonna do that right now. Actually, yes. I'm gonna paint this so I would be able to understand. What am I doing? That's not the color. It's from here to the same place. Here we go. Now I'm gonna save that. Great. I'm gonna disconnect, delete that. And gonna place it to the screen. Like this, and then I'm gonna wire it like this. Oh right, I forgot what kind of screen it is. We need an AND gate here, because we can write directly to the screen whenever we want. So we have pretty much direct access to each pixel of the screen. So I need an AND gate for that. we go. Now I need a block right here, which would actually set the pixels to the screen. There we go. And now I have to connect them to the white gates right there. Like that. Okay, now each time we set a pixel, we need to count up. So we need a counter. I'm gonna use where this counter that can kind of count each tick. Kind of, because now I know that it can't really do that, but it's still good enough. It can count each second tick. Also kind of. So each time we set, we increment, and we obviously do that to our input right here. To the decoder. So now that's done, and now what I need to do is I need to have scanning end, which would scan the image. And I'm gonna do that with pistons. I'm not sure, I'm gonna have it like 32 blocks away, for example. And here we will have an image. Maybe a little bit up, like that. But that will be an image. Which we'll scan from... I don't quite remember, are we starting from the top or the bottom? I'm gonna set to check. Okay, thankfully we're starting from the top, so we can, I think we can bring that down. There we go. And so now we're going to place the pistons right there. Not sure how good of an idea it is. Oh, okay. Yeah, you know what? It's probably better to have the... Yeah. It's probably better to have the image a little bit up so we could place the pistons below so they would push the thing. The sensor array. Okay. So I'm gonna place them. I actually need to make it more up because there is more pistons. I'm gonna place it later. So pistons. And I'm gonna probably use something like this. Oh wait, no. Yeah. Fortunately, I couldn't easily place it like that, but it's fine. There we go. Actually, I can just put the sensor things right there. So now, I need sensors, and I'll place 4 of them. And then just copy them. That's white, right? Yes. Might have placed this thing a little bit too far away from the actual image, so I'm gonna place it closer. And then I'm gonna place the sensor things. Sensors. So they would sense the color white. Okay, now I have to place them. I think like this. Yeah, nice. And so our image will end right here, because we're gonna make it count down a little bit jankier, I think, but you know, it's fine. It's fine, it's fine. It's going to be okay. This is our beautiful, beautiful screen that we're gonna transfer. I could make it with logic, but logic, it's a little bit bad in this, for this. So let's paint something. Actually, that might not fit with this font. Whoops. Consistent letter size. I don't know what am I doing, but we're gonna do something with it. Like, I don't know. It's 8 by 7 blocks and doesn't display much right now. I just made a prototype CRT like display. It's 8 by 7, doesn't do much right now. It's nice. Make it do ray tracing. Oh shit. No one saw that. No one saw that either. Anyway, this is the beautiful imagery that we're gonna transfer to the... hopefully. So first, what I would like to do is I would like to have the ability to full reset this thing. It will be quite nice. So I'm gonna add just this small gate right here, which will do just that. There we go. So that will go right there. That will go right here. And I'm gonna place a small button right there. And so it will reset the screen and reset the counter. Perfect. Now what I have to do is I have to actually transmit the data. So I need to plop the transmitter a tiny bit close to the ground, I think. But it doesn't matter. Actually, I'm gonna wire it so that it would be like that. But then into here, we need to write data. And we can do that like that. So very, very simple. Also, we need to make an inverted counter for this thing. Here we go. Then we need to make counter. But let's first connect white to white. Like that. There we go. So, now we can send the data, except we can't, because we need to do a lot more stuff. And that will be the counter. This one. And we need to invert, flip the bits. Because we're scanning from the top. And also I need a reset here too. Nice. Now I'm gonna place that somewhere around, I don't know, right here. Doesn't matter, it's a prototype. And then I have to wire the logic. Of course, I haven't changed the settings for the pistons, but I'll do that. So this one will go 8, this one will go 4, this one will go 2, and this one will go 1. I think I can do that. For speed. We'll see. We're gonna test it with this speed and then we... well... yeah. Okay, so we transfer the data. And after we have done that, we should receive... yes. Hold on, I'm gonna... right. Well, obviously, yeah, there is nothing here, but... oh, wait, have it? No, I haven't counted. Okay, so, when this thing is done, we get the signal from here, which we could use to actually set our thing. And we're gonna do that after one tick passes, I think that will be. Because like 1 it activates, 2. And then 2 it outputs. Or it doesn't. Do we have anything here? No, we probably don't. Because here we don't have anything. Okay, let's just count up and let's... whoops! I've messed up. The bits. Yeah, this is supposed to be like that. Whoa, wait, wrong. Yep, here we go. Now it works. So now we actually have some data here, which we could transfer. I'd have a... well, it didn't work, that's... yeah, we need more delay here. Let's set a timer then. 2 ticks. Full reset. Oh, that's... need to tick it. Now I have the data. Oh. Shit. Have we actually done anything? I think we did. Let's wait 2 ticks then. Okay, no. No data. What? I mean, something is happening, but the thing is, it doesn't do anything. Do we have data here? Wait, we have nothing here. What? That's not how it's supposed to happen. Well, we definitely do receive stuff. It's just that for some reason it doesn't really do anything. Let's make this an OR gate and let's just ignore that it will blink. Oh, it doesn't have any data written on it. That's interesting. So my transfer doesn't work. What? That's interesting. No, the line is not empty. Like here's the line. It's not empty, but for some reason, wait. Ah, I see the problem. I'm not writing it in the first place. That's why I'm not receiving anything. Okay, that does make sense. I've just forgotten to actually check that. Okay, I didn't write anything into here. That's why we don't see anything. So yes, I think we need to like increment. Okay, wait. Reset it. There we go. So let's make it a little bit more automatic. It's definitely not what I wanted. But anyway, when it finishes doing that, we need to wait some time because the and wants to set it to. I don't know how much do we need to wait, but we'll wait and increment. After we increment, we need to, I don't know. Oh, we need to wait till the actual things reach the counter. Reach the correct line, so we need to wait for that, and I have no idea how much time it takes. Say 250, because they're very slow. And then we can do that. And I'm gonna place that. So let's try to reset it. Ah, yes, makes sense. Yeah, you know what? Sure, let's just... Oof. Oh, oof. Well, it's probably because they're not on the same page on speed. Although I don't know. Okay, hold on. I transfer the data, and it's transferred. Here we go. We have data here. Oh, and it just didn't write. Oh, because I still not writing anything to it. God dang it. Yes, when we reach the thing, we also need to write to it. Not activate it, but write to it first. Can you spawn the logic gates in the correct orientation? I think a sim alert display would work better, but you're doing this already. Ah, smaller. Jesus, the spaces. So, right. So I don't think that the size of the display will matter a lot at all. I mean, the head will be a tiny bit lighter, but I don't think it will really matter too much. So, okay, I need to... My keyboard hates me. Buy a new one, so this won't hurt you. So we need to do that, I think. So let's reset it, and let's try that out. Oh, shit. Oh, yeah, it does make sense, because we have, again, direct access to the logic. Okay, but I see this tiny artifact right there. And that artifact is related to the fact that you can see here, here, and here. Those pixels are the same. That means that the thing is not fast enough. Well, there is always a solution to the speed part, and just increase it. Let's reset all of that. Yeah, whatever. It almost works fine. Just jitters a lot, bit. Okay, I think I can't set the speed for this one too fast, because it has a freaking hell. I think it's better to make. Yeah, I am making it. I am waiting for it to move. Wait, what is? No. When we... Oh, okay, what? Okay, I need to figure out my order of operations first. Set the piston 1 to speed 2, piston 2 to speed 4. That's very slow. That will be very slow. I don't want to set them to small speeds. Let's see how much it jitters if I'm just gonna... and piston 4 can be max. I'm just gonna... Wait, where is the button? There we go. Let's check how much it jitters. Okay, I can see that doesn't really jitter in a significant way. Like, I can see jitters, but if it jitters less than the half of the block, then it's completely fine. Yeah, it jitters less than a half of a block. When we have transition to 8, it jitters a lot. I could account for that, or we could just not bother. I'm picking the second one. So what we need to do is I need to figure out the order in which the operations will go. And so first what we need to do is we need to actually set the data. No, we need to wait. This is for the loop, by the way. So we need to wait. Make it see where the sensor line is. No. That will make... that will add more sensors and more weight. It's easier. Although... I don't know. We're just gonna have things. Okay, so anyway, we're gonna wait. I think 275 will be, or 300. Let's go 300. Then we're gonna, after we set the info, we can send it. And then we're gonna increment. Well, that depends on this one. Then we're gonna just do that. I'm gonna have this thing right there. I need a tick generator for that. So send a pulse, goes right there. And this is already goes to increment. And if we need to increment, then we'll increment. Wait till it increments. It's like one tick, and then we loop back. Oh, I need an OR gate. Or, no, an AND gate. Oh. Well, it just did send something. That's nice. Hold on. So I need an OR gate right here. And then make a tick gen. Actually, no, this is an AND gate. Wait. An AND gate? No. I don't know. Let's pick an OR gate. So we send a signal, we wait, we set, we... when it finishes, it sends a signal right there. I don't need that. This... It's 2-speed. But they don't jitter too much. What's the point of this? Why would I slow them down? They're all on max speed. The first one is on a tiny bit, like smaller. But the other ones, I don't think I need to... Oh, wait, why is this not fast? But yeah, I don't think I need to do this to make them slower. This 2 speed 5, like that's slower than I have right now. And it doesn't jitter too much for me to do that. It jitters less than half a block. So anyway, we're gonna send signal right there to count up. And if we want to continue, then we're just gonna loop back right there. Making that in one line is a bad idea, but let's see how it goes. Well, it's still... Yeah, I definitely need it. Well, it just starts to override it. Almost correctly. Okay, let's disable it. Let's shoot. So what did it do? It jitters at line 8. Yeah, I can see that because it... Now, could I account for that? I think I might be. So I think I could account for the fact, because the switch here, I think is at line, when we switch from line 7 to line 8. So we could wait a tiny bit longer. So we could just add a different timing here. So this one is, I think it was stable at 250, and this one will be like 300 to 400. Although I'm not sure if this is possible. Okay, let's just ignore it for now, but we'll hold that idea for later. So let's... I think we can actually continue from here. Okay, just kind of ignored the line. Does it even send this line? Okay, we need to make it even slower than that. Let's go with 400. Also, we need to make it so it... hold on. I'm gonna stop right here. Oh. Yes, it did send a line. Nice. And it did load the next... Never mind. What are you gonna send? Oh, okay. Oh, right, I forgot how this is the input, right. So, I need to make it so it would stop it when it's, 0? Yes. When it's 0, then we're gonna stop. No. Wait, no. It's an OR gate. So in theory it should stop at 0. It stopped at 0, but I think it did reset. Resend the first thing right there. Let's try it. Like that. Ah, yes. I think we waited not long enough for the counter to update. Guess we could like wait a tiny bit longer then. Wait, no. So well, yes, we increment, we wait, and then we loop back. If we actually need to loop back, and if the thing is bigger than 0. Let's try it again. Shit. I guess it doesn't really work like that. Well, then we can just increment, loop back. Wait, no, do that. And of this thing, I guess we're gonna make sure that it's something, I don't know. You know what? Doesn't matter. Although we do have to stop it somehow. NAND then? There we go. Yeah, it stopped. Nice. So, here we go, it works. It worked, it transferred this data. Congrats me. How long does the stream go? 3 hours, pretty nice. Almost the same time it was before. So, we need to make this faster, I think. Because if it would be faster, it would be better. So how do I make this faster? I'm gonna move it 1 block. Where is the tool block editor? That's what I need. Does it preserve the timing? I doubt. 400 ticks it was. Let's go to 250 because I think it was stable at 250. Here now I'm gonna do it through some kind of gate like this. Then here we need to make it an OR gate. Yes, we're gonna make it an OR gate. And here we're gonna wait 400 seconds. I think like that. And so now this one will activate. Oh shoot, we need to actually wait till the thing updates then. Okay, well, this thing will activate when when these are activated. This one will activate. And otherwise, this one will activate. And I'm not sure how to make it otherwise. No, I guess when none of those are activated, so the opposite of AND. Wait, it will just give it an input. No, not that. Because we can't really see what's happening. Okay, let's just have two of these things, and one will check for if it's 7, another one check if it's not 7. If it's 7, then we're gonna do this timing. If it's not 7, then we're gonna do this timing. Yeah. Okay, so now we actually have to wait a tiny bit till the counter actually changes its state. Oh wait, we need to navigate here. I could use that. And I have no idea how much do I need to wait, like 3 ticks. So let's see how it works, and if it doesn't. Oh, that's a very long yes. What the heck happened? Okay, I guess it can't have... It's not that stable at the timing I thought. Shoot. It still doesn't work. Okay, let's wait a little bit more then. God dang it. Maybe I'm just missing the point somewhere. Very important point. Definitely do. Let's just make it that, I don't know. If it even works with the like slowest. No, okay. Okay, let's just have a constant timing, whatever. It doesn't really save that much time. And it's certainly a headache if we're gonna have a not constant timing. Just have 400, 400 works fine. It's fine. It's completely fine. Rip? Oh, I should have actually... Yeah, if you're gonna stop it at this point, then it will not work. It's fine. Oh no. The medicine I take for my dust allergy causes headaches, and I can't eat before or after taking it. And the medicine I take for headaches can be taken without eating beforehand. So I need to wait 2 hours before I take it. Two. That's a lot of time. Also pain. That's unfortunate to hear. Guess they're not supposed to do that though. Wait, it doesn't loop back. That's why it doesn't work. God damn it! I forgot to connect stuff back. No, I'm just stupid. Dang it. Okay, let's just ignore what happened. Sure, it will be fine. Literal pain. Fuck. Ah, I'm an idiot. That's the problem. I forgot that I'm not supposed to connect this one to this one. Here we go. Bam. Nice. So that's perfect, it works. At the end of the stream, thanks for watching everyone. Thanks Ethan Stewart for joining in, aka Rat. Thanks Debel for joining in too. I really appreciate it. So yeah, thanks for watching and bye. See ya.